Hello everyone and welcome to my video tutorial on Introduction to Computer Programming using Python Part 1. This is the 12th class of a series and it is the final class of this Part 1. The topic is Code Testing. Objectives. We will learn about the general concepts of code testing in Python, to describe and implement the steps to build a test case using unit test, to write programs to implement function testing using unit test, to write programs to implement class testing using unit test, to identify and differentiate between passing and failing tests, to apply the setup method to create tests. Motivation. Testing is an important topic that many programming students fail to learn. For software projects that involve significant development effort, it is important to test the critical behaviors of the functions and the classes. This will help you to be confident that new work on your project won't break the parts that already work well, and to fix problems easily when they arise. This is a common experience for people who work with compilers and programming languages or other software. Whenever there is a new update, people generally check out for bug fixes, so it's common. So testing your program will help you to avoid such kind of problems, even though it may not be totally possible to avoid all of them, but it will help. Responding to a failed test that you ran while you are testing your program is much easier than responding to a bug report from an unhappy user. In addition, other programmers will respect your projects more if you include testing, because it's going to make your programs more reliable. Also, if you want to contribute to a project that other programmers are working on, you will likely be expected to show that your code passes existing tests. And usually, you will be expected to write tests for new codes that you introduce to the project. So these are the reasons why you need to understand code testing. Contents: Introduction to code testing in Python, unit tests and test cases, testing functions. We'll create a function to test, a program that uses the function just to show that the function is working. We'll create a passing test, a failing test, responding to a failing test, adding new tests. Then we'll create a class to test, a program that uses the class just to show that the class is working, a passing test, single response, a passing test, multiple responses, using the setup method for efficiency. Assert methods available from the unit test module. Learning outcomes. At the end of a class, participants should be able to explain the basic concepts of code testing, describe and implement the steps to build a test case using unit test, write programs to implement function testing using unit test, write programs to implement class testing using unit test, identify and differentiate between passing and failing tests, apply the setup method to create a test. So we'll go straight to Introduction to Code Testing in Python. After writing a function or a class, of which most of the software programs you write will be made up of functions or classes mostly, you can also write test programs for such code. Testing proves that your code produces the output it is supposed to produce when given the corresponding input it is designed to receive. You can also test new code incrementally to make sure your changes won't break your program's existing behavior. So today we will learn to use Python's unit test module, build a test case and check that a set of inputs results in the desired output that you want. see what a passing test looks like, see what a failing test looks like, unit tests and test cases. The unit test module from Python standard library provides tools for code testing. So we define a unit test as a unit of code that verifies that one specific aspect of a function or class's behavior is correct. One specific aspect. A test case is a collection of unit tests that together prove that a function or class behaves as it is supposed to, within the full range of situations you expect it to handle. So we talk about a good test case, which is one that considers all the possible kinds of input a function or class could receive, and it also includes tests to represent each of the situations. Now we'll talk about a test case with full coverage. So this is the one that includes a full range of unit tests covering all the possible ways you can use a function or class. So writing tests or creating tests for your code for a very, very large project can be very daunting. It's quite a lot of work. So it is advised that it is good enough to write tests for your code's critical behaviors. In short, you should start with the critical behaviors first of all. And after all of them have been tested, you can go to test every other area of the code. So, with unit tests, you can set up a test case, add one or more unit tests for your functions and classes. Let's go straight to testing function. A function is usually required for a test. So, we start by creating a function we call a name function to demonstrate automated testing. Def get formatted name first last. So what it does is takes in a first and a last name, and then it returns a neatly formatted full name. So here we have full name is equal to f string first and last. Very simple program which we have seen before in the course of this tutorials. So we return full name.title, which capitalizes the first letters in each of the names. That's what it returns. So to prove that our program is running, we'll just write a program that uses the function. We'll call this program names.py. So it uses function name function to demonstrate testing a function. So as usual, we will import it. If the function we previously created and this new program we're writing now in the same directory, then we can call the function as a module. So we say from name function import get formatted name, which is the only function at the moment in the file in the module name function. And then we'll begin to use it, or we'll try to use it. Print enter q at any time to quit, while true. First equal to impute, please give me a first name. If first equal to q, break, get out of the program. Otherwise, request for the last name equal to, please give me a last name. If last equal to q, break. Otherwise, formatted name equal to, we call the function get formatted name first last. And then finally print neatly formatted name is the output of the function call. Now if you run this program, this is what you get. Shows that the function is running very well. So we are going to go to Visual Studio Code now to run the program and see how it works. So here we are in Visual Studio Code. This is name function.py, which is the function we created. Now if you look at this function here, there are some other codes. So at the moment we will assume that this is the only item that is in this file, which we just described, and then we open the names.py that uses the function. and run it. So if we click here to run, then it asks for a name. Neatly formatted name, James John. Q to quit. So we can see that the outputs from the name function are correct. The program runs very well when you enter two names. In fact, it just asks you for two names. However, suppose we want to modify the program, the function getFormattedName, so that it can handle middle names in addition to the two names, and we want to make sure that it does not break the way it's already working perfectly, the way it handles the names that has only two, first name and last name. So how do we do that? Whenever we update the program, we could be testing with two names in addition to testing with three names, or two names and a middle name. Every time we modify, we begin to run the test the way we did it before by using the previous program that uses it. But this is going to become a tedious process. So that is where test automation comes in. So we can automate the testing of getFormattedName. In that way, we can always be confident that the function will work when given the kinds of names we've written the test for, whether it is first name and last name or first name, middle name, last name. The function should still work. So let's create a passing test to begin with. We are not updating the function yet. We just want to create a unit test that uses the function. So we call this testNameFunction.py to demonstrate test automation using unit test. So there are 4 steps to go about this. The first step, we are going to import the unit test module from Python. So we say import unit test. In the second step, we are going to import the functions that we want to test. So we only have one function at the moment. It is the getFormattedName. So we say from name function import getFormattedName. The third step is we will now create a class that inherits from unit test.testCase, because we want to make a test case. So we say class names test case. It could be anything. Make sure that the class you are creating has a descriptive name that shows what you want to do. The more important thing here is it inherits unit test.testCase, which is what we have in this bracket. So the fourth step is to write a series of methods to test the different aspects of the function's behavior. Any method that starts with test and an underscore follows and whatever else you write, it will be run automatically whenever we run this program we are creating right now. So we define the test, the method test first last name. That is descriptive enough. Self. So the function continues. Within the method we just created, within the test method, call the function to test. So we create a variable and say formatted name equal to getFormattedName James Sullivan. And then we call unit tests assert method, one of the methods. We see the rest of the methods there later, but however, let's begin with this. We say self.assert equal formatted name James Sullivan. When we say formatted name equal to getFormattedName, and then we call it using these two names. So this one is a string that is returned now, and then we'll put the string here, and then we'll put an equivalent string here. So whatever we have on this side is the output we are expecting from our function, and this is a string we create here. So assert, what assert is saying is, I want you to assert to me that the output we get from the function is equivalent to the string we have on this side. Do names like James Sullivan work on this function? The next code is to write something like this here. If underscore underscore name equal to underscore underscore main, that will call unit test dot main. So what does this mean? The if block looks at a special variable called name, which is set when the program is executed. So if this file is being run as the main program, the value of underscore underscore name is set to main, just like the way it is here now. Because we are going to run this test name function directly as the main program, that's why we set it to main like this. And after setting it to main, we call the unit test function, which runs the test case. However, if this file test name function.py is being imported by another testing framework, this program is not being run as the main program, the value of name will not be set to main, and this block will not be executed. However, we won't go into that now because this is an introductory part of testing. We are still on the basic foundations of Python. If you run this program, this is what you get. So we have a dot here. Whenever you see a dot in the Visual Studio Code window, you know that the test passed successfully. One test passed successfully. One dot tells you one test. Two dots tells you two tests, and also it tells you it ran one test in 0.000 second. Maybe it was 0.0001. It is abbreviated here or something. Then it finally tells you the test is okay. This is a passing test. We are back in Visual Studio Code to look at the test name function program which we just described. So this is the program which we just described. And then if you look at this program, there is also another test. This one is the first test that we are doing now. Test first last name. And then we are going to see another test here because it's written incrementally also. Now let's concentrate on this one. So we assume that our file only contains this part of the test at the moment, and we'll run the program. Right, so it says it ran one test in 0.00 second and is okay. You see the dot here before the line shows that our program, our test is running successfully. This is automated. You see, we didn't need to type anything on the keyboard before we ran the program. So the previous test shows get formatted name will always work for names that have a first name and a last name. But what happens when we modify get formatted name? So if we go back to the name function and we modify something, for example, we now want to get first, middle, and last name. And then we say get formatted name first, middle, and last. We also want it to generate a neatly formatted name. This time we say full name is equal to F first, middle, and last, and then we return full name title. If we go back and run the test again, which we created before, it's going to be a failing test. If we use the same two names that we had before, the same test that we had before, it's going to be a failing test because the program has been modified. So here we are back in Visual Studio Code, and then we go back to the name function. This time around, we are going to uncomment the second code and comment the first code. So we have modified the code. What we have here now is def get formatted name first, middle, last. Save the file. Open test function name and run it again using this test which we created before. Okay, so we now have a failing test, and it tells you type error. Get formatted name missing one required positional argument which is last. So let's close this again and go back to the name function. This time around we are going to uncomment this. So we have two functions: get formatted name first last, get formatted name first middle last. And then let's come back to the test and run the program again. Okay, so it says run test in 0.003 seconds. Failed test, error is equal to 1. So there's still a failing test here, meaning that we need to do something more. When a test fails, you don't need to change the test. Leave the test the way it is. Instead, you fix the code that caused the test to fail. The error we got was type error, get formatted name, missing one required positional argument last. There is one thing that can be done to do that. We can make the middle name optional in the program code. This is something we have done before, so here we are trying to remake it and try to use unit tests to make it work more efficiently. So we are back in name function. We now add this code, create a test case for first, last, and middle. If you remember when we were learning about strings in the earlier parts of the tutorial, we handled this issue before. So in different locations in the world, people answer different amount of names. In some countries, people just have a first name. It's common in some parts of the world. They just have a first name, no last name. The general thing is for people to answer a first and last name. Some have a middle name, some even answer four names, especially like in Latin American countries. If you want to make your program adaptive in such a way that it can be able to answer a first name and a last name and optionally answer a middle name, what you do is make the one you want to make an optional, you make it an optional argument. So we set middle to an empty string here, such that if somebody enters the middle name, it is accepted. If somebody doesn't answer a middle name, there's no problem about that. But you have to handle this situation in the code. So we say if middle, that is if the middle name was entered, we say full name equal to first, middle, and last. Otherwise, if the middle name is not entered, we say full name is equal to F, first and last, and then we return full name dot title. In that case, we have been able to use one single function to handle the situation for the two previous functions we created before. So if you go back to run the test, you will discover that the test actually runs. See, the same test we have before actually runs. So we'll come back to name function. Now we have created this code to handle the previous two functions. What I'm going to do now is uncomment this last one, which is the one we just described, and comment out the two tuple. So we say get formatted name first, last, middle. Middle is optional. The optional argument should always come last after the other arguments. Now our test name function has not changed. We still have test first and last name. So what we are trying to do at this stage is to check whether, since we have created an update, we knew before that the update we previously created, whenever we run the test, we get an error. It has broken the previous code. So we went back and updated the previous code with something like this. Now let's come back. We didn't change the test. We are not going to change this test. Rather, we are going to create additional tests. Let's run this test again to prove that the response we did to our function is good enough to pass the test without changing the test. So we run it again. So we ran one test in 0.00 seconds and the test is okay. It was successful. So When a test fails, don't change the test. Rather, you fix the code that caused the test to fail. And then you go back to test it to make sure that the test is running. You didn't change the test, you changed the code. The code is running very well. When given the desired input, it produces the desired output. What you should do now is, for the new code that you have added, you will now add a new test as it is required. The new code we added was to not only to accept first name and last name, but to accept first, last, and middle name. That we have not created a test for. For that, now we are going to create a new test and add or include to the previous test. So we are updating test name function.py. These dots you see here shows that the previous code still remain. They have not been changed. The same class name test case has not been changed. The name of the class has not been changed. All the remaining code, the previous method that is there has not been changed. That's what these three dots indicate. So def test first and last name is still there. It has not been changed. We'll now add a new test. Test first, last, middle name. Take note that this test underscore must precede whatever name you are going to give to the method. So what we are trying to do now is test whether three names work. Do names like James Patrick Sullivan work? Again, we say formatted name equal to get formatted name James Sullivan Patrick. Take note, here we have James Patrick Sullivan. The middle name should come last. In the creation of the function, the definition of the function, in the parameter list, it is the middle name which is optional that came last. So since Patrick is going to be middle name here, that's why it comes last here when we call the function. So we'll still use our assert. Self.assert formatted name James Patrick Sullivan. Do names like James Patrick Sullivan work? And then we'll go on to create our if statement again, name equal to main, because we are running this directly from this file that we created it in. And then we call unit test.main. Now if you run this program, you will see the two dots on top here in the output that tells you that two tests ran successfully. And it actually tells you run two tests in 0.00 seconds and both of them are okay, meaning that the function works whether you enter just two names or you enter two names with an initial or three names. The function works perfectly. So here we are back in Visual Studio Code. This is the second test we created. Additional test to test for the initial scenario. We'll now comment this out. Save the file and run it again. Okay, I'm going to pull this up so we can see the dots clearly. It's not showing them. Alright, so we see the two dots here that tells you two tests ran successfully, and it actually tells you run two tests in 0.00 seconds and the output is okay. So that is how to do code testing, unit tests for functions. Now let's look at testing classes. We are going to create a class to test just like we did for functions. We create a class and call it a name, anonymous survey, which collects anonymous answers to a survey question. Def init self question. If you don't know about classes, please go and look at our past tutorial on classes to understand it better. So we store a question and prepare to store responses. We say self.question equal to question, whatever question somebody puts there when the instance of a class is created. Then we'll create another variable called self.responses, another attribute, which is an empty attribute in this case. It's an empty list. Responses is a list. And then we'll create another method This is the initialization method as usual. It's now we are beginning to actually create our own methods. So method show question self, show the survey question. What it does is just print self.question, the question the person entered, the string the person entered when the class was instantiated. Another method, store response method. The user has to enter an argument for this parameter new response. So we say self.responses.append new response. This list that was created here inside the definition, we append the response to the list. We are beginning to build the list up. Another method, show results self. Show all the responses you have been given. First of all, you print a message that says survey results, and then we create a for loop for response in self.responses. So responses is a list, so there might be more than one item inside it. That's why we use the for loop to loop through. And then we say print f response. Now we have to create a program that uses the class first of all to show that the class is working before we go and create tests. We will call this program language survey.py. From survey, import anonymous survey. Define a question and make a survey. Question: what language did you first learn to speak? And then we create an instance of the class anonymous survey. We call it my survey equal to anonymous survey question. Now we call the method inside anonymous survey that actually shows the question, my survey.show question. Print enter q at any time to quit. We are now planning to get responses. While true, response equal to impute language. If response equal to q, break. Otherwise, my survey.store responses. We are now calling the method store response inside anonymous survey, and we take whatever response the user entered and put it inside. It's now going to be appended to the previously empty list responses. Now we show the survey results. Thank you to everyone who participated in the survey, and then we call the show results method inside anonymous survey, my survey.show results. When we run the program, this is what we have. Sends a message: what language did you first learn to speak? Enter Q at any time to quit. I say English, and then I say Q. Thank you to everyone who participated in the survey. And then you see survey results English. Just only English was in the list at this time. So here we are. This is a class we created, class survey, which we described in the lecture. We'll close it. And this is the file that uses the class survey. We just want to prove here that the class is working. This is not a test, just to prove that the class is working to begin with. So we run the program. What language did you first learn to speak? Thank you to everyone who participated in the survey. Survey results: Spanish, Okwe, Mandarin. So we see that our code is running perfectly. The class is okay. So now let's create a passing test for this class to show that the class is actually working. So we'll call this passing test single response. Take note of the test that we did using the program that actually ran the class. See, several people are supposed to respond to the test, but I was responding alone. So let's look at single response. We'll call this test survey.py to demonstrate class test automation using unit test. As usual, we import unit test, and then we say from survey import anonymous survey, and we create a class test anonymous survey which inherits unit test.test case. Let's begin to create our methods. We say def test underscore store single response self. We will test that the single response is stored properly. So we say question, what language did you first learn to speak? My survey equal to anonymous survey.question. My survey.store response Spanish, or whatever language you want to put there. This is a single response. And then we say self.assert in. We now say Spanish my survey.responses. So what we are trying to say is, if you have a single response, look at this. Here we said my survey equal to anonymous survey question. Now this is a class which is an instance of anonymous survey. It does have methods, so when we are trying to assert, what we are going to be taking is the method that actually corresponds to what you entered, and what you entered is the method that corresponds to that is responses. So that is why we are saying my survey.responses, because classes are things, unlike functions, which is just something like a method in a class. So that's the reason why we need to use this dot to take care of this method. Responses in the class is what corresponds to the response that the user put in the question. That's why we use this assert. That is what we use this assert for here. So the same way we still go back and say if underscore underscore name underscore underscore equal to main unit test.main. Now if you run this program, you will discover that the test is successful. It ran in 0.00 seconds. Here we are again in Visual Studio Code. We are now going to open the test survey.py. As usual, this is incremental. So since we are doing the test for single response, I'm going to comment out the test for multiple responses that we have here, so we can see how the first part of, or the first unit test is running. As we progress with the class, we'll come to look at the second part. This is the first part, single case test single response self, and we run the program. Run one test in 0.000 second, and the test is okay, and this dot tells you that the test was successful. Right, so there will be multiple responses the way the class has been created. We have tested that a single response functions successfully. What about when there are multiple responses? Does it also function well? We are now updating test survey by adding more code. Every other thing remains the same. We import anonymous survey, test anonymous survey, the same class. We just need to add a method. Test store single response remains the same. Every other thing remains the same. And then we begin to create a new test for 3 responses case. Test store 3 responses self. Test that 3 individual responses are stored properly. So we still follow the same procedure. What language did you first learn to speak? My survey equal to anonymous survey question. Now this is where things begin to change. If we create a list that contains 3 languages, English, Spanish, Mandarin, we no longer use just one single string. The previous time, which was Spanish, we now have a list instead. This time around, we can now say for response in responses, because we have a list, mysurvey.store response, whatever response. Each of them is going to be stored, appended to responses. First of all, English is appended. Secondly, Spanish is appended. And thirdly, Mandarin is appended. And then we'll go back to say, for response in responses, we are going to be asserting them one by one. Response, my survey, assert in. Is response actually the same thing as my survey.responses? It's the same thing we did previously. The only difference is, because we are dealing with a list here, we are now using a for loop to perform repetitive action. Finally, we'll come to the final if name equal to main unit test.main. When we run this program, it is successful. It says it ran 2 tests in 0.001 seconds, and both of them were okay, no errors. So here we are back in test survey. See, we did not update our original class because we didn't do a failing test. Okay, so we are going to uncomment this part of the code, which is the second part, the update, the new test we created. And then we'll run the program again. Alright, so it ran 2 tests in 0.00 seconds and the 2 tests were okay. So we are looking at something called the setup method, how to use the setup method for efficiency. In the test survey.py, we created a new instance of anonymous survey in each test method. You can observe that in each test method we had to create a new instance, and then we created new responses in each method. Even though it worked perfectly as we saw, but it was a repetitive process. So for 4 responses, for 5 responses, and so on and so forth, it's repetitive. Unit test case class has a setup method that allows you to create the objects once, and use them in each of your test methods, as many test methods as you want to create. So when you include a setup method in the test case class, Python runs the setup method before running each method, starting with test underscore. So any objects that have already been created in the setup method are made available in each of the test methods that you write automatically, so you don't have to do them all over again. So how do we do that? We'll call this program test survey2.py, which also demonstrates unit test, but this time using the setup method. As usual, we import our module anonymous survey, and we still say create test anonymous survey unit test case. So we say def setup self. We'll create a survey and a set of responses for use in all the test methods. Question: what language did you first learn to speak? See, it is inside this setup. Self.mysurvey equal to anonymous survey question, and then we'll create the responses. Self.responses equal to English, Spanish, Mandarin. Continue the program. We have done with the setup method. Everything that is in the setup method does not need to be repeated for every other test method that we are going to create. So if we say test store single response self, we can just directly say self.mysurvey.store response self.response 0, because it was inside the setup method. Let's go back. See, self.mysurvey has already been created here. So we just call the store responses or store response inside self.mysurvey, and then we call the response that has already been created in the setup method. We don't have to respond in every test that we create now. Self.responses. For the single test, we take only the first item, and then we say self.assert is self.response 0 is the content of response 0 inside the list responses. That's for testing the single response. For the 3 responses, test store 3 responses, we follow the same procedure. We just say for response in self.responses, self.mysurvey.store responses response. For response in self.responses, self.asserting response. See the difference. Response self.mysurvey.responses. So we are looping through each response in self.responses. And finally we do the if. Now when we run this program, it tells you it ran 2 tests in 0.00 seconds and the 2 tests were okay. So here we are in Visual Studio Code. We call this test survey 2 because there is a significant change in the program. This is the setup method we just described. So a lot of things were done here so that they don't have to be done in every other test that we write. So you see that the test codes have become actually shorter because this part has been automated. You submit the question here in setup. You get the responses here in setup. The only thing you do in the test is you store the responses, the ones you need to store, and then you test the responses whether that's actually what the output is supposed to be. So we run this program again. Successfully. So we have successfully used one of the assert methods available from the unit test module. However, there are other assert methods available from the unit test module, and we are going to look at them one by one. So we'll look at the method and the use. Assert equal AB. What it does is verify that A equal to B. This is the one we have been using. Assert not equal. Verify that A is not equal to B. Assert true. Verify that X is true. Assert false. Verify that X is false. Assert in. Verify that the item is in the list. Assert not in verifies that an item is not in the list. So we have come to the end of the class today, and our textbook still remains the book of Eric Mathis. So far we've come to the end of the first part of the Python tutorials. This is part 1. We are going to look at the topic covered so far in these 12 videos. This demo is presented by Bridge Kashore and is credited to him, which is Python Roadmap. So you can see all the things that we could have learned or we can learn in Python. Like I said before, this is a very basic introductory course to Python. So what have we been able to cover? We've been able to cover the basics of Python and a little bit of advanced stuff. So if you come to this point, you see the basics. We learned about the basic syntax, variables, data types, conditionals, loops, exceptions, functions, lists, tuples, sets, dictionaries. What else did we learn? We also learned about functional programming. We've been writing a lot of functions. What else? We learned about object-oriented programming. We learned about classes. We learned about inheritance. We learned about methods. Because if you don't know object-oriented programming, you cannot be able to learn certain things in even in the basics, like what we did in the class today, testing. We couldn't have done it because we needed to use classes. And what else we learned? We learned about unit testing. So you can see that in testing in Python, unit testing is just a small part of it. It's the beginning. There is also integration testing, there is end-to-end testing, there's load testing, so there's a lot of work to do. Now when you look at what we have been able to cover in this Python roadmap, you discover that what we have done is learn about the foundation of Python. There is still more to learn. In the part 2 of the course, the second part of the course, we'll be looking at a web framework, and that will be Django, and it's a full course on its own. So please like, share, comment and subscribe for more video. Thank you and see you in the next class.